We have talked through the reasons why sustainability and recyclability are important to EV batteries. Now let's put them in a context of cell-to-pack design and see what they mean from a battery design point of view. The traditional approach to construct a battery pack is first to assemble battery cells into modules and then modules into packs. Packaging at the module and pack level adds weight and redundancy and therefore reduces energy density. While a cell-to-pack design significantly reduces the number of modules and even completely removes the module-level assembly, building the whole battery pack from cell level. The benefit is that this design reduces the complexity of battery architecture, enables higher manufacturing process, and lower cost. An important feature of cell-to-pack design is to use more bonding materials to assemble the whole structure together. For instance, sono-conductive structure adhesive is used to bond battery cells to cooling plate. Potting resins or foams are used to bond the cells, battery trays, and lid together. Well, as mentioned before, the sustainable elements of battery design requires to consider repair, rework, reuse, and recycle. This target is seemingly going against cell-to-pack design, in which battery structure is more compact, less modularized, and more difficult to dismantle. So there is a strong need to reconcile these two trends. We can take a closer look at the major steps of battery repair, reuse, and recycle to get a sense of what might be the problems to solve. The first problem to solve is to understand the health and performance level of used lithium-ion batteries. Data such as battery chemistry, form factor, years of use, origination needs to be collected for analysis. State of health needs to be determined in a cost-effective way. And similarly, internal resistance of battery needs to be tested. All the data combined together serve the purpose to determine whether a battery can be repaired or reused or should be recycled. The second problem to solve is to disassemble the battery pack. As we mentioned, battery packs designed to achieve structural integrity has brought significant challenges for disassembly, and we'll talk about this point later in details. The final problem to solve is an efficient recycle process. As we mentioned before, a recycle process needs to be both cost-effective and green. Valuable materials such as lithium and cobalt need to be recovered as much as possible. Important metals like aluminum and copper also need to be recovered with a fine design process. The energy consumption and overall cost also need to be attractive.